Um, Good day, everyone. I don't know if the people present here can see me and can see my screen.
Yes, we can.
All right, thank you. My name is Daniel Owulabi, and I work as a junior data scientist at Amoye. And today we'll be, can you see my screen, please?
Yes.
All right, thank you. So today we'll be going through introduction to Kubernetes, like in Kubernetes, right? So pardon me, I'm having some issues with my system response. Okay, so the primary thing we'll be using today is this repo. I mean, if you want, you can go and clone it and work with it. My username is Daniel Tonoa, and it's on GitHub. So I'm supposed to include more things here. I probably would at the end of this session so that you can have a more descriptive README to be able to navigate this repo. So first of all, where do I start from? Let's see. So today we'll be talking about Dockerizing. Since we're talking about introduction to Kubernetes, I reckon you guys have read what Kubernetes is, so I won't be going a lot into the theory. We just want to demonstrate few things, especially with Minikube, which is a single node cluster for Kubernetes. So I'll be talking about Dockerizing a simple application, and then that we're going to expose as a web service, and then we are going to like interact with it on a Kubernetes cluster, right? So before we do that, we need Docker, we need Minikube, we need a virtual environment, because it is the virtual environments that are used to package the application that we're going to be working with. And then we need kubectl, which is a utility in Kubernetes to interact with the Kubernetes cluster itself. Now, I think we already know what Docker is, so I don't want to explain Docker again, like I said initially. So to install Docker, you can go either of two paths. I reckon that a lot of people will probably be using Windows system. So it is, let me just click this. So we have Docker site here. So you can just go and install Docker desktop. I don't think you can do that now and set everything up now. But if you have done that before, I mean, you can follow along. So download Docker desktop for Windows. You can download for your distribution, whether Apple or Linux here. But if you are not using that, there's a way to just install Docker using docker.io. So I'm coming. Okay, can you guys see my work environment?
Yes.
All right, so thank you. I have already cloned the repo. So normally all you need to do, I mean, I think you should know how to clone a repo, is come here and code, copy this, and then go to your this and git clone that, right? So, but since I already have it here, I'm not going to do that. So this is the repo here. I'm going to just enter a cd into it. And I think I was about to explain how to install Docker. So before you do anything, maybe you want to update, in case you're working on a VM, I would advise you do that actually, because a VM, I mean, using all these Google Cloud providers, either AWS, what they call this now, Google or anyone, they can provide VMs for you. You can set that up and then install your environment there. So you want to do a sudo apt update, you will run this. After running that, you're going to run, what do you call it now? You're going to run sudo apt install docker.io. So after these runs, you are going to see a lot of logs showing you the progress of what you're trying to install. Then since you don't want to be using what they call this now, sudo every time you're running Docker, because sudo is just saying that you have the privilege of administrator. You don't want to use that. You're going to add it to your user. So you're going to say sudo user mode, this exact command. Don't worry, I'll put all of these things in the README so that you'll be able to have access to it. I've not put it there yet. Then another thing that we need apart from Docker, that's for Docker. Like I said, you can go through everything I said now to get Docker up and running and it will work fine. Or you can install Docker Desktop from this README that I put here. Or you can just Google Docker Desktop, right? So another thing that we need is Minikube. Now, to get Minikube, I think I put that here. To install Minikube, we need to download the Minikube binary file. So you're going to use Core. Core is a command line tool for interacting with web sites, web servers, and all of that. So Core, using this particular argument, we are going to install this Minikube binary file. When we have it, we are going to install the downloaded binary file using sudo install Minikube. This particular command, I don't want to like be reading it. I mean, we can see it, right? Can we see my screen, please? I just like knowing that people are following me. Hello? Are you guys still with me?
Yes,
thank you very much. So Minikube start driver Docker. Now, the situation I am, these particular commands, right, are for Linux distribution. So if you are not using Linux, if you are using something else, you can go to Minikube documentation here, right? And you will find a lot of directives as to how to start running. I mean, this for Windows, and these are the commands that you run. Just copy it, paste it in your command line, and run it. Copy this one, paste it, read everything, and then you'll be able to get running. So I think that is that. I don't want us to waste too much time on that, right? I'm using for Linux, so that's what I was talking about for a while now. Then after we have Minikube running, so if you're using Minikube desktop, it is important that you set the driver. Sometimes it is not. It is able to just detect Docker as your driver. Sometimes it is not. So it is probably good that, I mean, if you say Minikube start, if you run into an error, then that's when you should try to run these commands, specifying the driver that you want to use. The next thing that we need is kubectl. So like we downloaded the binary file for Minikube, we're going to download the binary file for kubectl, and then we'll change the mode. So I can actually run these commands actually. I mean, I just don't want us to waste too much time on it, so that I don't be too abstract. I'm just telling you to run some commands and all of that. So let me just say I copy that. So it's going to download all of that. This is what you are going to have, right? After installing it, you change the mode to be executable. I mean, this is ch mode, change it to an executable file. I move it to your path. You move that particular executable file to your user local bin directory like this. So this is still going to be populated, don't worry. This working with Kubernetes cluster, but I'm going to try my best to show you every command that I'm running, obviously. So, I mean, let me see, ls. So this is kubectl, you change the mode, then you move it to your path, like I said. Right now, I'm going to just remove it because I don't need it. I've already done all of that. So let's go to where we're going to start today. So when you have Minikube and Docker running, you can do a Minikube version command, right? Minikube version. So I already have Minikube running. I mean, one thing to confirm that is Minikube status. So Minikube is already running, and then I have my control plane that controls the cluster running. I have the host, the kubelet, the API server, and the kubeconfig. Now, the control plane, as you must have read in your material, is that particular part of your cluster that controls everything that is going on in your cluster, right? It is through the control plane that you are able to create resources, delete resources, create storage and other objects that you have in your Kubernetes cluster. Now, the host can be several. We can have several hosts, but since we are using Minikube here, I'm running a single node. It is actually still possible to use Minikube to run several nodes, but in this particular session, we're using a single node cluster. So we're only having a single host. So kubelet is that particular agent that is on all the nodes. So the ideal situation that we want, let me do something. I should have gathered all of this. So I'm just checking Kubernetes online. Okay, coming. Let me check this image. So as you can see here, we have control plane. I mean, we must have seen this image somewhere before. We have node. This, so in my own situation now, since we're using Minikube, we have just a single node that we are going to be running our applications on, and each node has a kubelet. So the kubelet it is through the kubelet that you're able to interact with the control plane with the API server, right? So if you want to interact with each one of these nodes, you are going to be using kubectl. That's why we installed kubectl the other time. It is through kubectl that we are going to be interacting with a lot of the resources we have on our Kubernetes cluster, right? I'm just trying to do some kind of explanation here before we just set the ball running properly. I think I've used 12 minutes, so don't let me waste too much time. Today I want it to be kind of practical, since this is like an AI lab, and then most of the time we are trying to use Kubernetes resources to scale machine learning applications. So let's say that you're a data, there's a data scientist, and then they give you a notebook, right? I'm coming at my notebook run. These are the disadvantages of running locally, but it's taking a while for me. Okay, so now this is a simple flow for like a simple machine learning scenario, right? So we have importing of our major libraries I want to use with this particular machine learning problem. I just want to create context into the application I will be working with. So I already have in this repo a directory called data. It contains the data that we're going to be using to train the model. It is this model that I want to build a Flask application for. That's why I'm going through all of this. So this command, we read, then we have some kind of pre-processing that we are doing on some rows, some columns in the data. We are not going to be using all of them since it is just to demonstrate. So I'm picking just these columns, this column, and then what they call it now, the duration. I kind of engineered all of that. So you can go through this notebook on your own, right, to check each one of these codes and what they are doing. I think they are kind of straightforward. Here, this duration, I'm subtracting the Hello?
Hello.
Can you guys hear me, please?
Yes, yes.
All right. I think I lost you guys for a moment there. So we have pick up the time, drop off the time. It is with these two values that I'm able to get the duration that will be our target variable for this particular model, right? So we do some kind of processing here, and then I trained a simple linear regression model, right? And then I use a dict vectorizer for the encoding. I don't know if you guys are familiar with all of these words that I'm talking about. I mean, you guys should know some. I'm just going to assume that you guys have worked on machine learning workflows before. So I use the vectorizer to get the one that's encoding for the categorical columns, and then to just leave the numerical columns like that after turning them to a dictionary. So this dict vectorizer is just like the sklearn, the usual sklearn way of using fit transform. So I'm going to be using this dict vectorizer in my application so that I'll be able to do whatever it is I am doing while training my model in production when I'm trying to predict. So so that's how this whole workflow goes, right? At the end of the day, after training my linear regression, I pickled it and saved it as a pickle file, saved it in this directory that we have here, right? So I have models linear regression bin. So I saved it there. Okay, if you run this, it's going to create that directory for you and save it there. So I don't want to do all of that. I don't want to go through all of that. I've already done that before. You can run this, play around with it. So after I have that particular binary file, right, I now move that binary file to a new folder. called Flask application, right? You can call it anything you like. So this is that bin file that I pickled, right? So this is that bin file. So with this bin file, I am going to be creating a web application, and I'm going to be using this predict.py file. So what this predict.py file does is basically that I import pickle because I need pickle to unpickle this particular file, right? I need Flask and all of that. So you can create a requirement file, right? You can create a requirement file and put all of these things there, the libraries that you need. And like I mentioned on the repo, you need pipenv. I think it is somewhere here. I said pipenv. You need a virtual environment. So it is a virtual environment that I'm using to make sure that everything I do when I am working on this particular module will be done using the same libraries and all of that. Because when there is inconsistencies in library, it is possible to pickle something with sklearn of version 1.1 and try to unpickle it with version 1.3, and then you run into some issues or something like that. I'm just giving you an example. I'm not saying that's exactly going to happen if you try it. But to avoid that, that's why you need a virtual environment, so that virtual environment is what we take into our production, this particular application that we're trying to create. So say you created, let me just show you probably what you are supposed to do. So let's say that you are in change directory Flask application, right? You have not created all of these files, right? So you can just touch requirements.txt, right? So using this requirement.txt, I can just specify, I'm sorry, all of these things that I'm doing is if you have not created all of this. But let me just put it there and say you need pip, you need what do you call it now? sklearn. You need what else? You need Python. Although you can specify the Python that you want to use with pickle, with pipenv. So you need sklearn. You need what else? Let me go and check that file. Okay, you need Flask. So you need sklearn, you need Flask. So with this Flask and all of that, you can now install these particular libraries in your particular directory. So I don't want to go into the details of all of this. I know you people probably have a way that you deal with environments initially. That's not what we are working with here. The main goal of all of this, we want to play with Kubernetes. So in that environment, if you had used pipenv, because the gist is that when I want to create this particular application, I used pipenv. I already installed pipenv. Pipenv is the virtual environment true. So because I've already installed it, if I run pipenv, you're going to see the kind of commands that you can run. So pipenv, I can specify the Python that I want, maybe Python 3.9, Python 3.10. So if you use Python 3.9 when building your application, you have to specify that here too. So say before I created all of these files, I can do a pipenv install, right? Specify the requirement, and then I'll specify that requirement file where I have put all the library that I used when I was working with this particular what do you call this now? Notebook. Are you guys following me? Do you guys understand what I'm trying to do? Hello?
Yes. Yeah.
Okay, yeah, thank you very much. So I can say pipenv install -r requirements.txt, and then I can specify the Python after space. Okay, let me just finish writing that. I'll delete it anyways. -r requirements.txt that I created. Then I can say the Python that I need is Python equal to 3.9, right? And then I'll run this. So pipenv is going to install a new environment for me in that particular directory, this Flask application directory. And then when I run and when it finishes and installs all of that, it's going to create two files. That's what this pip file and pip file log is. So what these two files are doing is that I am going to be able to copy this into my Docker container. Now, I think we already know what Docker is. Docker is a containerization tool. It helps us package our applications. So in this case now, I'm going to be relying on the virtual environment files, this pip file and pip file log. As you can see here, it contains Escalate 1.1.1 and Python version and all of that. When you do pip-env install and all of that, it's going to create this file for you. So I need these two files in production, right? So it is with these two files that I'm going to transfer everything I'm doing here into my Docker container that I want to run my web application in. Is that clear, please? So I'm now going to, let's go straight to Docker. Let me just leave this. So Docker, because I don't want us to waste too much time. It's already 12:21. In a Docker file now. So essentially, you have these requirements.txt file. You have run pipenv install -r requirements.txt. Don't worry, I'll try to put all of these things in this particular repo so that it will be more relatable, right? So you have run this pipenv install -r requirements.txt. It's created these two files. Now you are trying to create a Docker file, right, for your application. So in my Docker file, the way Docker file works is that you need a base image. Now, all of these popular software applications have done it in such a way that they create an image, because this is changing the industry, as we must have heard. Containerized apps are changing the industry. That's why you guys are even here learning Kubernetes. So all of them have an image that they have created for their applications. There's Python. I can show you that here. Let me see. Let me go to that repo. I think Docker org. Let's just go to Docker org and see what's there. So if we go to Docker org, I don't know why the network is taking this much time. Pardon me, please. Okay, this is. So in Docker org, we can just go to explore, right? If you go to explore, you will see a lot of images. You have Ubuntu, you have Python, you have Postgres, a database. You can work with that. You have Redis, data warehouse. We have Node if you are coding JavaScript and all of those things. So using any of these base image, we are going to create our own image. Do you understand? That we want to use for our own use case. So I'm basically using a Python base image here. Let me just click on Python here so that you guys see. So Python has a lot of images. These are the images for different versions of their programming language. So I'm in Python using 3.9 Slim. I'm using 3.9 Slim so that it will, since I don't need a lot of what do you call it now, other applications or other utilities in Python. I need something small that I can build on. That's why I'm using Python 3.9 Slim. You can use any image you want. And then basically I'm going to use run pip install -u pip. So I need pip in my environment, right? So I'm going to install pip and upgrade it. Before you do this, you can put a run sudo update environment, but I didn't put that here. It is not needed. So sudo pip install -u pip, you install pip. I install pipenv, which I used. Yeah, you know, I already have pipenv in my own working environment, right? But just imagine that this file is the container. So in the container is empty. I'm starting from a Python image. I'm installing pip. I'm installing pipenv. I'm saying run pip install pipenv. Then I'm specifying the worker directory. Okay, I'm saying this worker directory command is just going to create this app folder. So just like I have this Flask application folder here, it's going to create an app folder inside my container. So I'm now telling it that it should copy pip file lock to the current directory. I think we understand some things in command line before, please. Are you guys with me?
Yeah, I'm with you.
Okay, yeah, so I'm going to copy this pip file and pip file lock into the current directory, and then I'm going to run pipenv install. These particular arguments are just saying you don't need them. Pipenv install. I can just remove this stuff here. But since this is a production environment, I'm saying you should deploy it in the system. So say I run that here, it's going to pipenv install everything that is in pip file and pip file lock that's specified in pip file. It's going to install it in my system. So this now, since a containerized app itself, just look at a containerized app as an abstraction that is its own system, like its own machine, right? Just like I have this my own laptop that I'm running all of these things on now. This container is empty, and I'm going to be installing everything that is in pip file on it, but I'm installing it on a system as a deployment, right? That's what this is saying. So now I'm going to copy again, predict.py, which is my prediction file. Where is that Docker file now? Predict.py. I'm going to copy this linear regression bin to, which is actually my model that I want to expose into the current directory. The current directory is up, right? Are you guys with me? So I'm going to expose port 8000, and then once all of these processes are done, it will run this command in the container itself. I think that is kind of straightforward. So let me just show you how that works in my own local environment first. So what we have here is predict.py, right? As you can see here, let's just quickly go through this code so that it's not so abstract for you. Yeah, I'm importing Pickle, importing the OS, importing the Flask application that must have been installed. So I open that linear regression bin, this particular model, I load it. So since when I was pickling it, I put the Dix vectorizer and the model in the what do you call this now? In the bin file. I need to load it as a tuple again. I don't think if you guys can remember when I was pickling it here. Can you see this? So I need to do that same thing. You can go about this in a different way. Do you understand? It doesn't have to be like this. You can pickle them separately and load them separately. I'm just telling you how I worked with this. So I'm going to create a function here. I created a function called preprocess. What the preprocess does is that it's going to take whatever ride dictionary that you send to this particular app, and then I'll create a feature from it, which is one of the things I did here. Right. So what I did here is that I have pickup location ID and drop off location ID, but I made them a single feature, right? I made it into pickup dnot by concatenating them into one. You can pick up location ID and drop off location ID are categorical variables, but I'm putting them into a single variable so that it can make my model better. I mean, I don't want to go into the details of that, but that's what I did when I was working with it. So I need to do the same thing in the prediction, right? So whatever ride you send it, it is going to have maybe pick up location ID dictionary, drop off location ID. Let me show you that. It's going to have pick up location ID dictionary. This is what it is. Drop off location ID. This is what it is. And then trip distance is going to be this. So I concatenated that into a single variable, right? And then, okay, let me go back to the predict.py. So everything I'm doing while I was working with this model is what I'm trying to do here, preprocess. So predict here is going to take those features, use the Dix vectorizer to transform it, and then I'm going to use the model to predict it. So it should return the predict of 0. This is because it is returning a numpy array. So the numpy array is actually a single value. I can test this for you guys before we actually run it in Docker container so that you can see what is going on. So I have the Flask. I don't want to explain how to run with Flasks, so to say, because our goal is Kubernetes. It's almost 30 minutes. So now, in this place, I have home. This is just a function. I'm using this decorator and the app, the Flask app, to route that. Okay, if you go to your home directory, this is what I want to show. I'm using this os.environment.get. So I'm getting environmental variables from where this particular code is running. And then if you want to actually predict, so this particular function is this is the endpoint that you will send our predictions to. So /predict. So I want to we use Flask request to load that JSON, this particular JSON that we have here. I want this to be open, but let me just open that test. This is the JSON file that you'll be sending to it. So I want to load that JSON, use my model to predict it, right? So I load the JSON, I preprocess it, I predict it using this particular function that I've created, and then I create another JSON file, predict.json. This is basically a dictionary that we said, okay, this is the duration I want and the prediction that I get, and then it will return the JSON file of that, and then using if name goes to main, I want to run this on my local host on port 8000. Do you get? So now this particular function, this particular what do you call this now? Sorry. Predict.py. I'm just so now I am in the Flask application folder. So now this predict.py file that I just explained to you guys, this is it. So I can do a Python. Sorry, I need to enter my ppm shell. So that's one thing you need to note. This particular folder now is where this Flask application is where I did ppm install and all of that I have all of this. So I can do a ppm shell to enter my virtual environment, ppm shell, right? I'm coming. Okay. I think something is going on. Mm, okay. Coming. Thinking during the time that I was playing around with change directory, that particular repo, change directory to the Flask application, right? So it can show. So now, as you can see here, it has loaded that particular, it will name that virtual environment, the name of your folder. So this is a virtual environment now. It's separated from my own system so that I can run my application with all those libraries that I installed initially. So now that I have done all of that, I can now say Python. So the Python, this Python, if I say which Python now, let me do which Python. This Python now is not using my normal base Python or my environment or global environment Python. It's using, if you look at this now, which Python shows me that this is the Python that it's using. Home, Daniel, Tomoa, and all of that, virtual environment, Flask application. So which is the Python that I installed in that virtual environment when I was doing ppm install and all of those things that I explained initially. So I can now say that Python predicts.py, right? So what's going to happen is that it's going to run my application on my own system, my local host that I have here. So now that I've run that, we can just come here and say localhost 8000, right? This is that stuff. So now my web application is actually running. Let me go to that web application. Is what we have here, right? Where is that predict.py file? Okay, as you can see, this I said the home directory should show these things, and that's what I have there. So I can actually run that test. Let me open another terminal. Can you guys see my terminal, please?
Yes.
All right. So let me just go to that introduction in that new terminal and go to that Flask application. Now, I want to show you guys something that I hope doesn't confuse you. This test.py now, if I show you this test.py now, my environment right now is running my env.conda. So if I change it to that Flask application environment kernel now, you will see that this request is going to say that it's not there. That's okay, maybe it's loading. But the point is that I don't have request in my Flask application. Okay, as you can see, you're saying that this request is not in the environment. That's because I'm using the Flask application, the virtual environment, as my environment for working with this particular file now. But if I use my normal, my env, which is my conda environment, it is there. I'm just trying to explain the concept of virtual environments to you and how it helps to package your application and separate things from other things. So now this particular test.py file now is just going to send this particular JSON to the local host predict endpoint and then get a response. So let's see what the output is going to be. Python test.py. Right, so we have the duration. Do you understand? So it has used the machine learning model that I created in this predict.py to predict that, okay, this is the duration that this taxi will take before you get to your destination based on your pickup location and your drop-off location and all of that. So duration is this. And then maybe we can connect this to some other front-end and back-end that, okay, use this to display on the front-end and whatever. That's not the main goal of this. So let me go back to my previous environment. So as I mentioned initially, I said this thing should run on my local host. So my local host in this particular scenario is my system. But now I'm going to create a Docker container. I've canceled that, Control C to cancel that. So I'm going to create a Docker container using this Docker file, right? And after I have, like I explained initially, all of these commands is going to run, and it's going to run this Python predict.py. So now, when this Python predict.py runs, it is not going to be running on my own local host again. It's going to be running in that Docker container, right, which is separated from my system. So to do that, I'll do a Docker build. I can tag it that, okay, I want to name this thing Danny Tomiwa slash, let me call it ride predict, right? And then with that, I can say that, okay, let me give it a version of 1. Then using the current directory, this is how you build. So I run this command now. It's going to build this image for me. I don't want to go through all of that. It will take a lot of time because I'm working locally. I would have done all of these things from the scratch, say I was using a VM. But working locally, I have to use my data, and then the network will take a lot of time. Trust me. So we don't want to do all of that now. I've already run this command, but this is what we run when you're in this particular folder. So it's going to build this application based on the name that you give it. So one thing that I have actually done to work locally is I use the command, right? I'm using my own local environment images. But on a normal day, after you have built that image, right? Let me go to this particular place, Docker images, right? So this is that image. Let's say this is that image, right? After it must have built it is this size. So after building it, version 1, as I specified, as you can see, it's 3 hours ago. I already did this a long time ago so that I won't have to be doing it now and I won't waste our time. I will now do a Docker push. This is the ideal scenario. You push this to your Docker hub. Now, in a situation that you have not logged in before, it can say that you should log in. So if you do a Docker login first, you put your username and password. What username and password am I talking about? The username and password that you created on Docker hub. I think I went to Docker hub somewhere here initially. Okay, yeah. So this particular Docker hub that I said that all these software providers have created their own images. You can have your own profile there, just like a GitHub repo. So this is my own profile, and I have a number of images that I have created from time to time. So as you are building the images, when you are done building the image, you will push it to this Docker hub after you must have logged in using the credentials that you created here. I think that's kind of straightforward. Please tell me you understand what I'm saying.
Sir, I have a question.
You ask your questions after, please. Can you like write it somewhere? Right. Thank you. So after you have logged in, you are now going to do the Docker push again. Normally, my own Docker push will work, right? It's going to push it to my GitHub repo. And I say GitHub repo, to my Docker hub repo. And this is that image here. This is it, right prediction. I pushed it a long time ago, in fact. But I was trying to pull it, and I have a problem with my Minikube, right? That I hope you guys don't run into. That's why I have decided to use the context of my local images. So what I did is that, I'm coming. Give me a moment, please. Coming, just give me a second. So what I did is that I used this particular command here, minikube -p minikube Docker environment. So I'm telling it that I should use my Docker environment for minikube, So all the images that I have already created in my local environment is what you should use for when I am running an application in minikube. What I'm saying, you guys will understand in a moment, so that it won't have to go to Docker hub to pull the image. On a normal day, after building your image and pushing it to the hub, right, you can run a YAML file on Kubernetes, and then it will pull that image and run it for you. You guys will understand that in a moment still. But instead of pulling it from a repository, I'm saying you should use my local images. I've already run that. So that's why in this place, if I do a Docker images, it's still doing this. So let me just run that command here. Docker. Okay, yeah. Sorry, the command that I'm supposed to run is this actually, this, right? Eval, it is eval this minikube docker env, not the initial one that I said. This is it. I actually had to go and check online for how to do that on using local images instead of having to pull it from the hub. So if I do a Docker images now, and something interesting is going to happen. Because I am running my minikube cluster now as an image itself. It is now showing me all of the images that minikube cluster is using: the API server, the scheduler, the control manager, the proxy, etcd store. I'm sure you guys have read all of these things in your material. So this is, I'm running all of these things now as images themselves. You get, as a kind of object in my particular Docker environment. You guys don't need to wrap around that. So so that now I can pull this Docker, this particular image that I built, right? This ride prediction image that I built with Docker build that I showed you guys before. I can pull it into Kubernetes when I want to. Are you guys following me?
Yes.
All right. So now, let me just do it clear here. Okay, so let us go to the juicy stuff. So now that I have built my image, I have pushed it. Let's just imagine that I have pushed it to my repository. And when I want to run anything now, I'm going to be pulling it from there. Whereas I have explained to you guys that that's not what I am doing. I'm using the image that I have in my local environment so that I can work locally. I don't have to go and be wasting my what do you call this now? My data, pulling it several times, because I'm in 640 something MB. It would have been easier if I was using a VM. So now let's just now check some basic things. Minikubes status, right? So it's telling me that everything is running. If you just install the minikube and you have not run it, you will do a minikube start, right? Minikube start, like I said, and then maybe when you're running before, you must have specified your drivers, but subsequently after running it the first time, you can just use minikube start. Some other arguments that you can give this is Kubernetes version, and the CPU that you want to use for it, the amount of memory of your system that you want to use for it, all of those things. You can check the documentation for how to specify them. I'm not going through all of that now. So after starting it, you check a minikube status, you're going to have all of this, right? So now let's now play around with some of these Kubernetes objects. First of all, let me create a deployment. Now in Kubernetes, right, we have several objects. We can have a pod. The pod is the smallest abstraction in Kubernetes. The pod is just you running your container in that pod. I think that's kind of tautology. So this container that we built using this Docker file is not going to be running that container directly. It is going to be running it in a pod on Kubernetes. So if I do let me do a kubectl now. I'm not going to be using Docker again. I'm going to be using kubectl to interact with my cluster. And one of the basic commands that you can actually check is kubectl version, right? So kubectl version will show you the version of the kubectl that you're using and the version of the Kubernetes that you're using too. I can also do a kubectl cluster info to see what I have in my cluster, like what kind of cluster I'm running and all of that. So you can see here that it's saying that the control plane is running on this particular IP address. And then I was expecting it to show me the version, but I guess it's just this that is going to show me where it is running and all of that. So that's not where I'm going. So I can say kubectl get nodes, right? Kubectl get nodes. It says that, okay, minikube is the kind of Kubernetes that I am running. And I have a single node. Say I was working in a production environment, maybe on AWS, and we're using EKS, EKS to deploy our application. We can have several nodes. Like I said, a node is a machine. A node is basically like your laptop. But if you're using a virtual environment now, let's say all these VM machines that we have on Google, on AWS, on Azure, a node are machines that you're going to have. So now imagine that you have several nodes and you're able to run your application on several nodes. What's the importance of that? We just want to have a resilient system so that in case one of those nodes go down, one of those machines go down, you can transfer your application to another node. Do you understand? So now in this case now, we are just using a single node, Minikube, because we are just trying to experiment with stuff. But I'm just trying to explain the concept of a node to you guys. So I can say kubectl creates deployment. Deployment is another object on Kubernetes, right? So I'm telling kubectl through the API server to create a deployment. So I can tell you that this deployment name should be ride prediction, right? Ride prediction is the name of the deployment, and then I can specify the image to be the image that I built, this particular image that I built here. So before I run this, let me just enter and give me an error. I intentionally did that. Let me do a Docker images, like I said initially, so I can get the name of that image. So this is the name of the image, right? Do you guys understand what I'm trying to do? So this is the image. I will now copy the name of this image. So I can go back to that command that I ran initially. Could say I'll create deployment. This is the name of the deployment I want to create. And then I'll specify the image to be that image name, right? So you can see here, it says that deployment apps write prediction has been created. So now I can say kubectl get deployment. You can see here that this is the deployment that I have. I'm coming. Get deployment. So I have these deployments now. Now a deployment will create a pod, right? So a deployment is like a pod is a subset of a deployment. Deployment is a resource on Kubernetes that will ensure that our pod is going to keep running. Because if we just run a pod, right? If we just create a pod on Kubernetes, a pod can die. Do you get a pod? A pod dies over time. But if we create a deployment, we can specify some other characteristics of the deployment that will keep the pod running. We can even say that we want more than one pod running. Let me do a kubectl get pods now. You can see here that it is running, right? I have this particular pod running duration app from that particular deployment. You know, I did not say you should create a pod. I only created a deployment, but it knows that for a deployment to run, it needs pods. So it's going to create a pod, and then that pod is running on this Kubernetes cluster, the Minikube cluster. Do you guys understand what I'm saying? So now, what is going to happen is that, you know, I have canceled all of those things that I ran on my local environments before when I went to localhost. If I go to localhost and I refresh, it's not going to work. It's not supposed to work. Why? Because Minikube has separated everything that is running in its cluster from this particular environment. Let's just say that this environment is the outside world. So everything that I'm running on Minikube is only local to Minikube. So this particular pod of this particular application that I created is only local to Minikube. So how do we get it out? We can use a kubectl proxy. Funny part is that I've not even tested this out, but let me just see. Kubectl proxy. Right. So now it's telling me that it has created this proxy here on this particular port on my local host. This kubectl is just going to, this proxy now is making sure that everything that is running on Minikube should be available on my local environment. Right. So now if I go to coming. If I go to this proxy now is showing me everything that is running on Minikube. Do you understand? It's exposing it on this particular port, 8001. So it is showing me everything that is running on Minikube at the moment, like all these particular objects that is running on Minikube. So let me show you guys something. I'm coming. So I can come to this particular what do you call this now, endpoint, and I'll be able to have access to my application that is running on Minikube. But this is pod name. This is supposed to be a command line statement. So let me just do something here. Let me come back here. So like I said now, kubectl get pods. I have this pod running, right? So I can, this is the name of the pod, right? So I can copy this name and put it there. Can you see? Do you guys understand what is going on now? So what is happening is that the proxy is exposing everything that is happening on Minikube to the outside world. I'm calling my local environments the outside world now, because normally Minikube cluster localizes everything in it to it, so that any outside what they call this now, resource or any random person cannot just interact with our application. We will see how to do that later on. So now, using the name of that particular pod that is running on my Kubernetes cluster, I am able to have access to it. Does that make sense to you guys? Are you guys following me? Using a proxy, because I ran this proxy now in another what do we call this now? Command line environment. So this kubectl proxy that I ran is just making sure that everything that is running on Kubernetes is exposed. If I cancel it now, if I cancel it and I come back here and I reload, nothing is there. Why? Because I am no longer exposing it. But this is going to be tedious. We can't be using proxy every time. So what happens is that you can expose your deployment. I already explained the concept of a pod. I already explained the concept of what do you call it now? A deployment, right? Now, another thing that we have on Kubernetes is a service, right? So for a service, we are exposing the pods that will be created by the deployment to the environment. Now, to which environment is now the question. There are several types of services that we can have. One thing that I want us to know is that each pod that is running on Kubernetes has a unique IP address. And like I said initially, pod dies, right? So normally, if I want to expose this application to the outside environment, I'm supposed to just say that I want to expose this particular pod, kubectl get pods, right? That I created. I want to expose it to the environment. But what if this environment dies? What if I'm trying to do a rollout or an update to this particular image? Do you understand? To do that, that's going to be tedious using a pod. So we use the concept of a service. A service is another abstraction that exposes a deployment to the outside environment. So to do that, we are going to do kubectl expose that deployment, the type of exposure that we want, and then the pod. If you guys check the material very well, you will have seen that services have different types. You can have a cluster IP. You can have a node port that uses network address translation. You can have a load balancing service, or we can have an external name that we are going to be able to give, like www.google.com. I don't want, let me see. I should have written that in the README file so that it will not be too abstract. But let me just mention that again. I'm sure you guys must have come across it before, so that it will just, what they call it now, ring a bell. We can have a cluster IP. We can have a node port. We can have load balancer, and we can have external name. Now, load balancer just makes sure that we are able to have several pods running at the same time, and then we can interact with several of them at the same time. Let me do something right now. I'm going to expose this particular deployment now that I created. kubectl get deployment. Did I make a mistake somewhere? So now this is the deployment that I have, right? So I'm going to expose these deployments now as a service on Kubernetes. And I've told you that we can have several types of services. So now I'm going to say Control V, kubectl expose deployment name, right? Now this deployment name here is going to be the name of our deployment, which is duration app, right? As we have here, when I did kubectl get deployment, duration app. So type as a node port on port 8080. But if I do 8080, let me just show you guys something. If I do 8080, now I have this particular what do you call it now? Duration app exposed as a node port now on my Kubernetes cluster, so that anything outside Kubernetes can be able to interact with it. If I use a node port type, I can be able to interact with it outside Kubernetes. If I use a cluster IP, like I mentioned initially, I won't be able to interact with it. But if I use what other type is there? What do you call it now? Load balancer. I will still be able to interact with it, but I will have the opportunity to interact with several pods at the same time. And then I can use an external name so that I will do some kind of domain name attachment to that. That's kind of complex and beyond the scope of what I'm trying to do here. So the entire thing I'm trying to make you guys understand from this is that you can expose your deployment as a node port, or as a cluster IP, or as a load balancer, or as an external name. So moving on. So did I run that? I can't remember. But let me do kubectl get SVC. As you can see here, that service that I created initially, this is it now. So with this, I am going to be able to access this particular application using this particular node port. Now, there's a problem with what is going on with my local deployment of Kubernetes. I'm guessing it's because I used Docker-based image, but that's not the point I'm trying to say. Normally, I'm supposed to be able to interact with this application on this particular node IP. This node IP that Kubernetes has given me, but it is not working. It just keeps running. So I'm guessing there's something wrong with my daemon. But the point is that I've been able to expose it as a node port with this particular command that I'm getting. Let's just go ahead and check some other things that you can work with. There's something called label, right? You can have a label for I'm trying to see if I should kubectl get SVC. Did I write something wrong? Okay, kubectl get SVC. So I can, just like I created it, I can say kubectl delete SVC duration app. So now I've deleted that service, and that service is no longer available on my Kubernetes cluster. So if I do a kubectl get SVC now, I don't have that particular service again. I don't know if you guys understand. I can delete this one too. Duration service. Okay. So kubectl get SVC. So now I don't have all those services that I created initially, but I still have those deployments. kubectl get deployment, right? I still have that particular deployment running. So now, if I delete, let me show you guys something. kubectl get pods. This pod, like I said now, is created from this particular deployment. If I delete this pod, kubectl, let me create another environment. Bash, because I want to do something. Let's watch it. Watch kubectl get pods, right? We can see that this particular pod is running. It's going to keep running. If I delete kubectl delete that pod that is running now. Oh, sorry, kubectl delete pod. I need to put pod there. Pod. Because you need to specify the resource that you're interacting with. kubectl delete pod duration app. So it deleted that pod. You can see here, it's terminated it, but it's creating it again using another pod name. Do you guys understand? So this is because the pod is continuous. We have already told Kubernetes that we want a deployment that's a duration app. If that pod dies, Kubernetes will just decide to recreate that pod again, because we did not say that we don't want that deployment again. The only way to get rid of that pod is to delete that deployment. kubectl delete deployment duration app. So now if I come here, I can see that it is terminating, but it is not creating it back. I don't know if what I'm explaining is understandable. Are you guys with me? Are you guys with me?
Yeah. Yes.
So deployment. As of right now, I only have this. Let me delete this particular deployment because I don't even know why it's there. Go to your delete deployment. Right. Okay. So like I said, a deployment is a higher abstraction for a pod, and then the service is the way that you are exposing your deployment either inside within Kubernetes using cluster IP or to the outside world using node IP. So like I said now, I said we can have several nodes. So if I use a node IP, it just means that that particular service is going to be displayed using this node, and other nodes or other things or Kubernetes will be able to have access to it. Or every outside user that has the IP of this node will be able to access that particular service using that port that we are exposing on that node. I don't know if what I'm trying to explain makes sense to you, but let's just go ahead now because I think we're already running out of time. It's already 1. So there's something else called replica set. kubectl get replica set. So we don't have any replica set in our what do they call it now? In our environment right now. So kubectl, let me go back here. I think kubectl creates deployments, right? Let me just create it again. Because I already deleted it initially. kubectl gets deployments now. So now it is creating that particular deployment for me again. But right now, if we watch it, let me delete this. kubectl get pod. Come. What's going on? Right prediction, image, time general, right feed. kubectl get Docker images. Okay, so it's not seeing that image. It's giving me an image pull back off. So it's not seeing that image that is mine. So let me just delete that particular deployment. kubectl delete deployment. Let me try to create it again. Still create deployments, right prediction image, done right click, kubectl get pod. Okay. I think it is because I ran it in another what they call it now, environment. Like I said initially, I had to run a special command that minikube docker env to make sure that it sees my own local images instead of trying to pull it from the Docker hub. I didn't run that in this environment. I only ran it in this environment. So let me do kubectl get pod again. Still now, right prediction. Okay. Let me try to run that command again because I'm trying to use a local give me a second, please. Okay, I think something is wrong with that image now. It's not seeing that image again. Well, I was trying to explain a replica set. I don't know why it's not seeing that image again. I mean, it was seeing it just now, right? But like I was explaining initially, a replica set is another abstraction on Kubernetes such that we can specify the number of replicas that we want. So a replica set just makes sure that we have several instances of our pod running on the Kubernetes cluster. So I was supposed to just show it here. So instead of having 0, 1 read here or 0 of 1, if based on the replica set that I specify, it's going to be running that same number of pods. So the command for running that is kubectl scale. So I'm going to be telling it to scale up my application horizontally. So it's going to be, I'm coming. kubectl scale deployment, scale deployment. So I'll specify the deployment name here and the number of replicas I want. And what happens is that instead of running just one pod, it's going to run 4 instances of that pod so that they can have high availability. So let's say that we have a lot of customers that are trying to interact with this particular prediction service. They'll be able to still interact with it if one is in use by some other person. So we can scale this up as much as the amount of resources we have on our Kubernetes cluster. Right now, I don't know why I'm not able to get that pod, that particular image running again. I think something has gone on again with this because it's right here, right? Okay, kubectl pre-deployment. Okay, let me do something, version 1. Incoming deployment. That might be it too. Duration prediction. Okay, some things are already getting. Okay, kubectl get deployment, right? So kubectl delete. Let me delete this particular deployment. I need to specify the resource name. Deployment, right? So let me create video. Create deployment. Then I specify the version. Okay. Record. Let me watch it. Wow, it's because I didn't specify what they call this now, the version. As you can see here, Docker images here. This is the image that I built for it, and it is version 1. So since I didn't specify the version, it did not know that this is the image I'm looking for. But let me quickly run that what do you call this now? That scale command now. So what I'm trying to do is that I'm trying to kubectl scale deployment. I think the name of my deployment is what? Ride prediction, right? And then I'll specify the number of replicas to be, let's just say 3. So now let me do kubectl get pods. You can see here that it is now creating 2 additional pods, right? So if I do kubectl get deployments again, you will see that it's going to be 3 out of 3. Right prediction. So now I have scaled it to be 3 different pods running on my container. So the importance of probably exposing that thing now as a load balancer or as a node pod is that normally though a service of exposing as a service is that a service has a load balancing feature in itself normally. So anytime that I interact with this particular prediction service, is going to be eating each one of these guys separately. So it is load balancing. That's how the load balancing works. So these 2 additional pods that I created are called replica sets. That's why I was saying that. Let me do a kubectl get replica set. You can see here that the replica set that we have now are 3: desired, current, ready, the age, 2 minutes. So the other abstraction that we have on Kubernetes, because I think we're already out of time, are config maps and secrets, right? So I will explain what config maps and secrets are in a moment, but just to quickly round this up, everything that I have been specifying can be tedious. Imagine that I have a front-end application, a back-end application, a database, and all of those things that I want to deploy on my Kubernetes cluster, the machine learning service itself, microservice itself. I can't be running them on command line. So the best way to go about everything that I have been explaining is using a YAML file. So if you come to this particular folder in the what do you call this now? In the repo, you will see this kubernetes.yaml. Let me delete everything that I have. kubectl get deployment, right? So let me do a kubectl delete it. Deployment. You can either just say deployment space, or you can specify a slash and put the name of the deployment, right? Prediction. So it has deleted that deployment now. Let me just confirm that I don't have it again. I don't have any resource again. I can try to check get pod 2. You can see that it is terminating everything and then it will delete it eventually. So what I'm going to do now is I'm going to create all of those things using a YAML file. That's what a YAML file is for. With a YAML file, I can specify all of those things at once. So the API version I want to use, the version of the API server for Kubernetes I want to use is version 1. There are several versions, I think, but it's version 1 we're going to be using here. So the kind of resource is the deployment. The metadata is just describing this deployment. So under metadata, I'm going to be using the name that, okay, the name of this deployment resource is duration app, right? This label is just to make sure that I can specify the pods specific to these deployments. Because like I mentioned initially, I can have several deployments on my Kubernetes cluster. But if I label them, right, I can say that if I'm looking for a specific, the pods that what do you call this now? That are specific to the backend, for example. Let's say I have several deployments for backend and for frontend. I can label them differently. Say that app, the version. I can say that maybe state or type. I can say backend here. So let's just now imagine that I have several deployments in this particular YAML file. I can now specify this type for them. So eventually, if I want to interact with those particular deployments separately, I can specify label, -- label when I'm using kubectl and say that I want to use the type of backend, and it is going to be able to select it out for me. But I'm just trying to explain the concept of labels here. So now we have the specification of what do they call this now? That deployment itself. So selector match label. So a match label is just a map of key value pairs. It is kind of like labels. The same way we have labels for that deployment, we can have the label for the containers that deployment is going to be running, right? I mean, the pods that deployment is going to be running. Like I said, a deployment is a higher abstraction for a pod. Now, the template for that particular deployment is the metadata label. I'm specifying that part, those labels that I specified initially again. So specification. So this container now will specify that image. The name of the container, I want it to be duration container. The image, I'll specify the name of that image that I created. Do you understand? Which is this image that I have on my cluster, Docker images. This particular image, I'm going to specify it. On a normal day, this image now would have been pushed to the hub. So you don't have to be running, because this is for experimentation purposes. On a normal day in a production environment, they will push it to a Docker hub so that anywhere we are running this particular YAML file, we can pull it from the Docker hub, the same way you can clone a repository anywhere. So the image pull policy here, I'm putting never, so that it won't try to go and be looking for it in the Docker hub. I am specifying that I want to use the local one I have in my local environment. I don't know if you guys are still following me. So the container pod that I want to open is 8,000 environments. This is specifying the environment name. Like I said, I wanted to use this to just explain the concept of config map and secret that I did not get to. You guys can check more on all these concepts here. Kubernetes, you can come here and check, what do you call it? Getting started, learning environment, right? And you can play around all of the juicy stuff that they have here. I think there's a way to actually learn on okay, let me see tutorial. So you can run this tutorial to get a good idea of what config maps. They will explain config maps somewhere here. The concept of security. You guys can explore more on all of this. It is actually kind of very interesting. By the time you try to play with it, and then you make sense of all those theoretical things that you are reading. So like I mentioned initially, so instead of, let me just go to configuration file, right? And then I can do, so as I have specified all of those things in this configuration file right now, this is the deployment, like I mentioned initially. We will now expose it as a service still, so that we can have access to it outside our cluster. So let me just do Kubernetes, kubectl, sorry, kubectl, am I right? Apply -f kubernetes.yaml. So what happens is that you can see here that it will create a deployment and a service at the same time. In another case, we can have several other objects or resources specified in this YAML file, and we'll be able to create them. And you can just check get pods. You will see that it is already running that particular application again on our Kubernetes cluster, but then we also have that service, kubectl get svc, right? It's also running it here. So that's where I'm supposed to stop today. Although I've rushed a lot of things, I didn't necessarily explain config maps. Maybe you guys should go and check it out yourself. But let me just explain briefly what that config map is now. So you guys can test it and play with it if you check the documentation. This particular Flask application that we run, right? If you check the predict.py, you will see here that I'm doing a os.environments.get. So normally you'll be writing code that will probably have to interact with the database. You need the username of the database. You need maybe the password of the database. You can't just add code it. Although here I'm telling it that os.environment.get will get the environment variable database username. It will look for this particular variable in the environment. If it doesn't find it, it will replace it with Postgres. But on a normal day, you won't even have this. It will just say maybe get this, right? Because we don't want to add code it in our what do you call this now? In our code. So what happens is that it looks at the environment to get this particular database username and database password. Config maps is what you use to create those particular variables so that you can inject it into this pod. So there's a way to create config maps. kubectl creates config maps. You will specify that you want to create the config maps maybe from your literal as a string or from a file, or you can create another YAML file for that config map. So you guys should go and explore that, and then you will run it. So whatever you specify in that config map, you'll be able to change this database username or database password using that config maps. As I've specified in this kubernetes.yaml configuration file here, I've already said that I want it to be an environmental variable, and then name, database or username, the value. This is the value that is going to use, right? New name. As of right now, I think before, when I can't remember if I showed you guys whatever the, it's before it must have used this particular value, Postgres and password, it must have displayed that. But now that I have I am using Kubernetes to specify the environmental variable. Let me do kubectl get pods, right? Let me do a port forward, kubectl port forward this particular pod, 8,000 on my local host, 8,000 on that particular pod, right? So now I can go to my local host because I'm using kubectl to expose that particular port to my local host. So I can come here and come to localhost 8,000, and I'll find it there. And you can see here that I have new name. If I change this environmental variable in this place to something else, say new clear kubectl delete, right, minus F Kubernetes. So I didn't do this before. I can delete all those resources at once using that same YAML file. Kubectl delete, specify the name of the YAML file, and then you have that here. And then, so let me create it again. Kubectl, I think I have saved it, right? Yes. Kubectl apply. I think I ran it recently now. Let me just write it. Kubectl apply minus F Kubernetes.yaml. Right, so it has created it. Let me go and reload this. Okay, it's not showing it again. Let me get the pods. Oh, sorry, it can't display it because I've not port forwarded. You know, the initial time I port forwarded it that I want to expose that particular pod to my local host. Oh, so get pods, this particular pod, I have to port forward it again. Kubectl port forward that port, then 8,000, 8,000. Yeah, right. So as you can see, it has changed again based on what I'm specifying in my YAML file. So what config map will do is that instead of specifying this value directly, I can say I want that value from, sorry, that was a mistake. Let me hash this. So I want that value to be from a config map reference. And then I'll specify the name of the config map that I created and then specify the key. You guys go and play around with this. I'm not going to work on this. So that's the end on today's session. Please, do you guys have any questions? Are you guys still with me, please? Hello?
Yes.
All right. So please, do you have questions? Time out gone.
Yeah, there was one I had as regards you pushing the Docker images to the Docker Hub. So I was trying to understand if Docker Hub is more like maybe version control stuff like GitHub, or just.
Yes, exactly. You know, I was saying initially that it is like GitHub, the same way you push your code now. If you come to GitHub, I think I opened GitHub somewhere here. Okay, thought I did. If you come to GitHub, you will find code on GitHub, and then you can clone code that they have made public. The same way we have Docker Hub is a version control site repository for images. So you can have your own account and have your images. These are my own images that I have created and pushed to my hub. You can create your own account and push your images there and make them either public or private, right? I can change the state of it so that, okay, I want it to just be private, in which case any random person won't be able to pull it. Right now, if you go and run Docker run Danny Tomiwa write prediction version 1 on your end, it's going to work. But if I change this to be private, it won't work on your end again. It will only work for me. I don't know if that makes sense to you.
Yeah, I understand.
Yes. So yeah, that's how it works. It's just a repository that you put images, just how you have it. All these software providers to have put their base images. So if you want to like play around Postgres now, you want to create an application that will interact with Postgres database, you can start with their image, in which case all of these things that I was talking about environmental variables to specify the Postgres username, the password, and all those things, you can specify them. Instead of hard coding them in your code, you'll be able to specify them as environmental variables and use maybe config maps that you can change over time to inject it into that particular pod that your configuration file will run. Any other questions, please? Please, did I answer your question?
Yes, it's clear.
Any other questions? I actually have a lot of other stuff that I would like to show, but time has gone. So you guys should just, as I advised you initially, you guys should make sure that you just come on this Kubernetes site. You will see a lot of things there that you can just play with to understand better what you guys are reading. Because if you are just reading it, trust me, you will forget. But when you play with it and then you're able to understand very well, okay, so this is what this thing is trying to do, this is what this thing is doing, and all of that. So if there are no other questions, is Christian there?
Yeah, Daniel, I can hear you clearly.
I don't think they have any other. Are there other questions that other
No, none on YouTube. I guess this is what we call it today.
All right then.
Thank you so much for that wonderful presentation. That was very, very interesting. Okay, in the absence of no further question, I guess we call it today. See you next time in our other coding session. Have a lovely day.